In this video, I'm going to be working through a worksheet activity covering the vertex form of quadratic functions, in which I'm going to be investigating the effects of specific parameters a, p, and q, and how they'll change the function and its graph. This video is meant to be watched after the beginning of the 3.1.2 video that introduces the vertex form. So if you haven't already watched the first 5 minutes or so of that video, I'd recommend you switch over, watch that, and then come back here. This video is not mandatory, it's just a nice way to double check and see if you did the activity properly. So you can also just skip to the end of the 3.1.2 video to see what the answers were if you're feeling confident in how the activity went. The start of the activity, we're going to ask you to just predict what you think A, P, and Q will do. So you've got a space up here, you can just write down some quick predictions and then double check how they went at the end of the activity. So the first thing that you're going to actually want to do is load up the website desmos.com. So on that website, whether you use the calculator or not, there is a graphing calculator. So this is what the website looks like. If you see that open graphing calculator button there and you click that, that'll bring up this. So I'll just do a quick tutorial on how Desmos works for the people who haven't used it before. So if you have used Desmos, feel free to skip ahead a little bit. The way Desmos works is it takes whatever equations you put in and it makes a graph of them. So you can see you've got a keyboard down at the bottom here. It'll look a little different if you're using a phone or a tablet or a computer, but the general processes are the same. On the left, there's a space for you to type in whatever equation you're looking at. So for example, if I wanted to graph a line, I might graph y equals 3x minus 2. And so if I type that in, I get my graph. It shows it all very nicely. You can change the colors. And you can have more than one graph on any particular grid at a time. So maybe I'll throw a second one up there, like y equals 4x minus 1. And so we can see we've got both of our graphs here. This is really helpful. It shows us how the things relate, and it graphs it really quickly. And this is going to be what we're going to use for our activity today. One other thing you might want to know is if you look to the left of the equations that we just graphed on the left side of the screen, there's a red circle and a blue circle, and we can use those to deactivate the equations so that they don't show up. So if I want to hide one of the equations, like say the red one, if I tap that circle, it goes away. And so it helps us maybe have multiple equations but not see them all at the same time. Another useful thing that Desmos can do is it can graph equations for us that have letters instead of numbers in some places, so parameters. If you're thinking, for example, of slope-intercept form, y equals mx plus b, which you would have covered in grade 10. If I type in y equals mx plus b, I get this. And so you can see underneath the equation on the left side is it has a pop-up that says add slider for m or b or all. And so if I hit all there, it creates these two sliders for me. And what those do is if I change the number that the value of m is, so right now m is 1, if I drag the slider to the right, it changes the number. And you can see it makes my line steeper because it's increasing my slope. So I can make it big, I can make it negative, and then if I change the b slider, it'll move my line up and down because I'm changing the y-intercept. So that is going to be very useful for what we're going to be doing today. So if you look back at the activity, the next thing it asks you to do is graph a couple of functions. So we're going to start off with y equals x squared, which I have already graphed here. So it's just a very basic parabola. This one we're going to be playing with as we go to see how different things change it. So the next thing you're asked to do is to graph y equals ax squared. So this is y equals ax squared. You notice they're the same because right now my a value is 1 if you look at the slider further down. But if I change my slider, if I maybe make it a little bit bigger, you can see it has an effect on the graph. And it looks like as it gets bigger, my parabola gets skinnier. We can also think of it as maybe getting steeper. It's going up faster. But what happens if I go the other way? So if I start to get smaller and smaller, okay, it starts to get wide. If I hit 0, it's now just a horizontal line. But then if I go into the negatives, we can see that the parabola is now facing the other way. So if you think of the direction of opening, one of those characteristics of parabolas that you saw, this affects a couple of things. So if we go back to our worksheet, if we're describing the effects of ax squared, well, a does a couple of things. When a is positive, the graph goes upwards. When a is negative, the graph opens downwards. And when a is large or it's close to 0, it changes the width of the parabola. So that's what I'll put up here. I'm not going to go through and fill in every single box of this activity, so I'm going to leave that to you. I'm just going to hit the high points. So that's our main effect. A changes the width and the direction. And if you look at 0.5x squared versus x squared, you can see it makes it a little bit wider. If you make it negative, it'll flip it upside down. So next we go to p. So go back to Desmos, and we want to be graphing now y equals x minus p squared. So I'm going to hide ax squared, open up x minus p squared. And so you can see it looks like it's roughly the same shape when p is 1, but it's over to the side a bit. So if we change p, if we drag this slider around, as I make p bigger, the parabola moves to the right. As I make p smaller, the parabola moves to the left. And when it's negative, it's on the left side of the axis. When it's positive, it's on the right side. So that's really helpful to know. So let's note that down. The general effect of p is it moves the parabola left and right. When p is positive, it moves right. When p is negative, it moves left. So that's p. Thirdly, we want to look at q. So same idea, we're going to be graphing y equals x squared plus q, which is this function here. And you can see once again, with q being 1, our parabola seems a little different. So if we move q and we make it bigger, you can see it slides our parabola up. And if we make q smaller, it slides our parabola down. It does seem, maybe from this perspective, that it's actually also changing the width of the parabola, but it's not. It's just putting it in a different spot. So it looks wider just because the vertex is lower, but the shape of the parabola is exactly the same. So our general effect of q is it moves the parabola up and down. When it's positive, it moves up. When it's negative, it moves down. And so if you look at that y equals x squared plus 3 that you're told about down here at the bottom, it's the same shape, it's just 3 higher. The whole graph has been moved up 3 units. And so that's our effect of q. And so if we move to the next page now, we're asked to make graphs of a times x minus p squared, ax squared plus q, and x minus p squared plus q. And I'll let you play with those yourself and try to recreate these 3 graphs. But there's a few key things we want to look at. So if we move to the next one, we're told to look at the vertex of the 3 graphs from question 5. Where are they located, and how are they related to the parameters of a, p, and q? So I'm going to look at a specific one. Y equals 2x squared plus, 2 times x plus 4 squared minus 1. So this middle graph here. Let's try graphing that. So I'm just going to play with my sliders to get them into the right spot. So a was 2, p was 4. But the dangerous thing to look out for here is that was not x minus, or x plus 4. That was x minus negative 4. And that's the tricky part about p. It's the opposite of what it looks like. Because if you're looking at the function in the equation, it's a times x minus p squared plus q. So if in the brackets you have x plus 4, that's actually x minus negative 4. And that's one of the trickiest things about vertex form until you really nail it down. So for us, I'm going to put in negative 4 for my p value. And then for my q value, I'm going to put negative 1, because that one's just exactly what it looks like. And so we get this parabola here. If we look at our parabola, this one, sorry, rather. If we look at this parabola, we're asked to where the vertex is. So the nice thing about Desmos, if you tap on the parabola, it'll actually bring up some specific points, and we can see the vertex is this one down here. So our vertex is at -4, -1. And if you stop and look at your equation, pretty quickly you'll start to realize that the vertex is located in a very specific spot. It's at PQ. So your P value and your Q value. And that's it. So if we look down to the next one, for the function 12 times x minus 13 squared plus 20, we want to find a few things. So our direction of opening, remember, for our three parameters, A, P, and Q, A is the one that decides whether we open up or down. Since A is positive, that means we're opening up. Our vertex is located at PQ. So for this function here, P is positive 13, not negative 13, and Q is 20. You really got to watch out for that. So that's x minus positive 13. Our axis of symmetry goes through our vertex, so it's going to be x equals 13. And then our domain and our range. So domain for parabolas is almost always going to be just all real numbers. So it's the x, ER. Our range is based off of our vertex. So our vertex here is at 20, and the graph opens up. So as a very, very, very rough sketch, our vertex is somewhere up here, and our graph goes up this way, which means our range, if we're looking at that minimum value of 20, we want to be above that number, right? The graph starts at 20, and it goes up from there. Okay. So the rest of the activity here is just some more practice. So go ahead and work on that on your own, and then feel free to flip back to the 3.1.2 video just to get a little bit more information on these things.